Well, now we're going to talk about wholes. Wholes in a rational function. Or, I guess say another way, a rational function with common factors. If a rational function has common factors, it's going to create a hole. It's going to be a spot, a point on the graph that x cannot equal, and it will create, because the function would be undefined at that point, and thus creating a hole. So here we got, for each function, determine any vertical and horizontal asymptotes, holes, and intercepts, then graph the function and state the domain. Well, before we get too deep into this, I've got, let's see, g of x equals x squared plus 10x plus 24 divided by, or over, x squared plus x minus 12. Now, probably the first thing I want to do is figure out the horizontal asymptote, because I'm looking to determine the horizontal asymptote. I'm looking at the degree of the leading term. I'm comparing that in the numerator and the denominator. And in this case, both of our expressions, the leading term is x squared. So they have the same degree. And when the degree is the same, we should know this now, then the horizontal asymptote can be determined by the ratio of the coefficient of the term in the denominator divided by the coefficient of the term in the denominator. And of course, in this case, well, it's just 1 over 1, which equals 1. So we're going to have a horizontal asymptote, and I'm going to abbreviate it. You may not like it, but I don't care, because I hate to write the word asymptote. I hate to even say the word asymptote. I remember one year I couldn't say it at all. I had to call on a student to say it, because I couldn't even get it out of my mouth. But right now I'm saying asymptote. Wow. All right, we got a horizontal asymptote where y is equal to 1. All right, now, before I go much further, I'm going to have to factor this numerator and this denominator. And if I find that I've got a common factor, I'm going to have a hole at that point. And once I factor out the holes, then I can go ahead and figure the horizontal asymptote. And we're going to use that also to find the intercepts. And then we're going to graph the function, state the domain. So let's see, x squared plus 10x plus 24. Well, I'm working on the numerator first. I need a couple of sets of parentheses. Since it's just a 1x squared, I'm going to put an x on the left side of both parentheses. I got a positive constant, and I got a positive middle term. Well, guess what that tells me? I'm going to have positive inside my parentheses. And I need two numbers that are going to multiply to 24 and add to 6. And looking at that, well, 6 times 4 is 24, and 6 plus 4 is 10. So how about 6 and 4? All right, now let's think about the denominator. Again, I'm going to draw two sets of parentheses. Since it's a single x squared, I'm going to put an x on the left side of each. I've got a negative middle term and a positive, I got a negative constant and a positive middle term, which tells me I got to have a positive and a negative inside my parentheses. And I need two numbers that are going to multiply to negative 12 and add to 1. Well, 4 and 3 seems to fit the bill. And I think if it's plus 4 and minus 3, 4 times negative 3 is negative 12. 4 minus 3 is 1. Hot dog. Now, look what I got. I've got an x to the 4th in the numerator, and I've got an x to the 4th in the denominator. And so at that point, x cannot equal negative 4, correct? And x also cannot equal 3, so I can knock out two things. So I'm going to have, I'm going to have a hole. We're going to have to come back to this hole in a minute. Well, let's just see this. If I set each factor equal to 0, let's do it this way. I can say that x cannot equal negative 4. And set the second factor, x minus 3, equals 0 or not equal 0. X cannot equal positive 3. Now that x cannot equal positive 3 is going to give me a vertical asymptote at that point, where x is equal to 3. So I'm going to have a vertical asymptote where x is equal to 3. I'm going to have a horizontal asymptote where y is equal to 1. I'm going to have a hole where x is equal to negative 4. However, I got to find, so for the hole, I also got to find the y-coordinate. Negative 4, comma. Now, how can I do that? Well, I'm canceling those out, by the way. Do I want to go ahead and do the hole, or do I want to do the intercepts? Let's go ahead and do the hole. All right, now if I substitute back in 4x into x plus 6 and then x minus 3, if I substitute that negative 4 in and solve it, that's going to give me the y-coordinate. So let's see here. I'm going to put it right here. So then I'd say negative 4 plus 6 over negative 4 minus 3. Well, negative 4 plus 6 is 2, and negative 4, negative 3 is negative 7. And so my y-coordinate with where x is equal to negative 4 is going to be negative 2 over 7. So I'm going to have a hole where x is equal to negative 4 and y is equal to negative 2 over 7. Let's see what else we got. See, we've done the vertical asymptote, we've done the horizontal asymptote, we found the hole, intercepts. Okay, let's see. If I want to find the y-intercept, I set x equal to 0 and solve. Well, okay. So then the y-intercept, let's do it like this. Y-intercept, set x equal to 0. So I'd have 0 plus 6 over 0 minus 3. And when I solve that, I got 6 over negative 3 or negative 2. And then if I want to find the x-intercept, I set y equal to 0. Y equal to 0. And the only thing I got to concern myself with is the numerator, because you know what? The denominator can't equal 0. So I'm going to say that 0 equals x plus 6. Subtract 6 from both sides. I got negative 6 equals x. I got an x-intercept at negative 6. Let's see. So what we got? We got a horizontal asymptote, y equals 1. We got a vertical asymptote, x equals 3. I got a hole where at negative 4, negative 2 over 7. I've got a y-intercept where at negative 2, and I got an x-intercept at negative 6. Shazam. Let's go graph this thing. All right, well, let's graph this thing right quick. Let's see what we had. We had x squared. Well, I better back up. All right, key point. Put the numerator and denominator each in a parenthesis, so your calculator reads it right. So I had what? X squared plus 10x. X squared plus 10x plus, what was it, 24? Yeah, plus 24. Close my parentheses. Hit the division mark. And set up another parenthesis. X squared plus x. I have to get on the wrong problem. And then minus 12. I didn't want that 6. Minus 12. Close my parentheses. Let's go take a look at our graph. Boom, boom. Okay, so let's see. Well, when x is equal to positive 3, I've got a horizontal asymptote. I've got a vertical asymptote. Can't really see it here where y is equal to 1. But particularly I want to go check my whole and my, so let's see, at -4 I'm expecting, well, I'll get to 3 first. All right, there's my vertical asymptote where x equals 3. And when I get to -4, shazam, how about that? There's another error right there, and we calculated the y-coordinate of that to be -2/7. So I didn't state my domain back on the other slide, so the domain is x such that x cannot equal -4. It cannot equal +3. I can see that there in my graph. But other than that, x is an element of all real numbers. All right, well, we got another one here, another function. We're supposed to identify, determine the vertical and horizontal asymptotes, the holes, the intercepts. We're going to graph it and state the domain. Let's start here with the horizontal asymptote. Again, I got the same situation. My leading term in my numerator is x squared. My leading term in my denominator is x squared. That's 1/1. I'm looking at the coefficients. The degrees are the same. They equal each other. Therefore, the horizontal asymptote is determined by the ratio of the lead coefficients. This is 1/1. And so I'm going to have a horizontal asymptote where y is equal to 1. All right, now I got to start factoring the numerator and the denominator. All right, so let's see. We got c of x equals x squared minus 2x minus 3 divided by x squared minus 4x minus 5. Now let's focus on the numerator first. All right, so I got a single x squared. I'm going to put one x in the box on the left side of the parentheses. My last term is negative. Well, that right there tells me that I got to have a positive and a negative inside the parentheses. I need two numbers that are going to multiply to -3, add to -2. Fortunately, the only two numbers that can even multiply to -3 that are integers anyway are 3 and 1. And so I think I need a -3 and a +1. Okay, that looks good. And then we got x squared. Okay, well, once again, I'm going to draw two sets of parentheses. We'll put an x on the left side of both since it's a single x squared. I got a negative constant, means I got to have a positive and a negative inside my parentheses. I'm needing two numbers that are going to multiply to -5 and add to -4. Well, 5 and 1. Okay, so -5 and +1. All right, well, I got a common factor. And I got a common factor where x at x plus 1, and if I set that common factor equal to 0, I'm going to have a hole where the x coordinate is equal to -1. So we're going to have a hole where x is -1. Now what will y be? Well, let's substitute -1 into the remaining factors. So I then would have, let's do it down here, -1 minus 3 over -1 minus 5, and that's going to equal -4 over -6. Well, my two negatives are going to cancel each other. It's going to go positive. And I can reduce that down to 2/3. So I'm going to have a hole where x is equal to -1 and y is equal to 2/3. All right, let's see. What about the intercepts? I guess let's just do, for the fun of it, the y-intercept first. Want to do the y-intercept? All I got to do is my remaining factors now. So I'm going to set x equal to 0 in both my remaining factors in my numerator and denominator. So I'd have 0 minus 3 over 0 minus 5. And so then I got -3, -5, but those two negatives are going to cancel. And so I've got a y-intercept, I'm going to do it like this time, at 3/5. Okay, what about x-intercept? Well, we set, only thing I've got to worry about on my x-intercept is the numerator, because in my denominator it can't equal 0. If it does, boom, we're done, we're undefined, we're just out of the question. So an x-intercept, we're going to set y equal to 0. So we'd say 0 equals x minus 3 and solve. And so when x is 3, we have a X intercept. So I got an X intercept at 3. Let's go ahead and do the domain. So let's see, we got X such that, what can X not equal? Well, X cannot equal. I got one more to do there. So I need to set, I got the -1. And I got that 5. Let's see, X minus 5 equals 0. Add 5 to both sides. All right, so X cannot equal -1 or 5. But you know what? Other than that, X is an element of all real numbers. We're going to graph this one too, just because I want to. I love to graph. I just love it. It's kind of sick, isn't it? All right, let's graph this second function right quick. I'm going to go over here. I'm clearing out what I had in the y equal. And boom, it's gone. I got to put them in parentheses, numerator and denominator, each in their own parentheses. Got to get where I could see this stupid function again. Okay, x squared minus 2x minus... What did I do there? That was weird. Okay, 2x. Oh, I don't see what I did. Okay, minus 2x minus 3. Close the old parentheses, hit the division symbol. Come back in here with another parentheses. X squared minus 4x and then -5. Close the parentheses, hit the graph button. Zip, zip. Okay, let's see. Out here at 5, 1, 2, 3, 4, 5. Looks like I've got a vertical asymptote. And x equals 1, y equal 1. See that one a little bit better. Looks like a horizontal asymptote. Let's go check our holes. I should have one. Where was it? At -1. Ah, yes, there it is. -1 with an arrow and 5 with an arrow. That's a hole at -1. That is a vertical asymptote where x equals 5. Don't you just love it when a good plan comes together, baby?